So my name is Lionel Bringuier. I'm working for Elemental Technology, which is a company, an American company, based in Portland, Oregon, and we have offices all over the world. And basically, we are providing solution for media processing to do some live or VOD streaming to any connected device. And I will tell you a little bit more about new trends that are changing really the video delivery model. So some of the topics we will be talking about today include multiscreen, which is today a reality. We'll see that very quickly. We'll talk about software architecture and why software architecture are mandatory to adapt to this ever-changing world of video delivery. We'll talk about adaptive protocols, which are now ruling the video market, and we'll have an overview about the future of the video market with new screens, new codecs, HEVC, also known as H.265, which will be the next big thing, and cloud architectures. So it will be rather technical. I try to make it as understandable as possible, but if you have any question, don't hesitate to ask at the end of the presentation. So what technology for the new video delivery? Video is everywhere. This is a reality we have today. There are some estimations that today we have 9 billion connected devices available. So there are more connected devices on Earth than human beings. Can you imagine that? And if we look at the near future, in 2020, there will be 50 billion connected devices. So video is everywhere. You're no longer watching TV only on the TV set, but also on a tablet, on a smartphone, on a gaming console, on PCs, on set-top boxes, and so on. And it's becoming something which is more and more in your work or in your everyday life. So, you know, in work, teleconferencing is becoming more and more used. It's the same for university. E-learning is becoming more and more common everywhere around the world. If we look at the figures, there is a tremendous opportunity for video right now. There is really a massive growth for digital video consumption. I have some examples there. For example, in the US, 85% of American people watched online video last year in September 2012. So nearly everybody, from a 3-year-old kid to 85-year-old granddaddy, everyone is watching video, may that be on YouTube or catch-up TV applications or things like that. Last month, half of the total web traffic in the US was devoted to only YouTube and Netflix. 10 years ago, Netflix was just a postal DVD renting company. They didn't have any online activity, and YouTube was created in 2005. So 10 years ago, those two companies didn't exist. Today, they represent half of the whole web traffic in the US. And as you can see in the diagram we have here, this is something which will be becoming more and more important, bigger and bigger for the coming years. And tomorrow, as you can see, it will be driven by mobile consumption and a convergence between classical TV and over-the-top, I mean internet TV consumption. One of the explanations about this rise of video consumption can be the availability of new streaming protocols that really eased the way of doing some video delivery over the internet. The problem we were facing for many years was the fact that watching a video was a very painful experience because of the buffering. There have been some studies that showed that buffering was killing the experience. For example, without buffering, one of the examples we have here, without buffering, users watch more than twice as much content as they would have when buffering is present. And for every 1% of increase in buffering video, the consumer will drop 3 minutes of watching. So we've seen, starting in 2007, 2008, new streaming protocols which are all based on the same principle, and those are the protocols we call adaptive bitrate streaming protocols. I will just explain you what is behind that. So adaptive bitrate streaming, the difference with classical streaming that you can have on IPTV or managed network is that there is not only one single stream which is sent to the client devices, but you have several qualities, several resolutions, several bit rates available, and the client will change smoothly its quality according to the network condition. So it will start, for example, with a very low quality, very low resolution, and if the client sees that it can get better resolution, it will switch up to the better resolution and so on, and it will adapt in real time to the quality it can have. So maybe you have heard about HLS, smooth streaming, MPEG-. All those are protocols, and they are all based on this same principle of chunking video segments and let the client adapt to what it can have in real time. Also, what we are experiencing today is that there is more and more innovation on the video field than ever before, and the pace of innovation is accelerating. So on this diagram, you can see some examples over the past 4 years of new technologies or new features that changed the video streaming. So there was HLS, of course, from Apple, introduced with version 3 of their iOS devices. Then the iPad, a real game changer, a tablet, which is today a device mostly used for consuming video. YouTube Live, then in 2011. HEVC in 2013, and 4K, the next bigger screens, and we'll talk about that later on today. So the problem is, if you see this acceleration in innovation, the market doesn't let the vendors have too much time before making those innovations available on the market, because today the consumers are eager and they are willing to get those new capabilities as soon as possible. Everyone now has a tablet. Everyone wants to consume video on their tablet, even if it's not always the same protocols and not always the same technical challenges that you have to stream from an iPad to an Android version 2.3 or Android version 4 or a Windows tablet and so on and so on. So if the pace is accelerating, as I told you, the vendors have to be very fast and react very soon. And I believe that the software approach is the one to choose. Here is a comparison between some of the latest features we introduced in our products, and there is the time delay between the introduction of what we did with a software solution compared to the availability of specialized chips, specialized hardware to do the same thing. So H.265, we'll talk about that more thoroughly later on, but today there is no encoding chip or encoding device, hardware encoding device available, and we already have some solutions from the software point of view. So basically, we are providing software. We are a software company, but we also bet on a disruptive innovation because we based our products on a combination between CPU, computer chips, and GPU, graphical processor units. So we use graphical chips to do media processing and video encoding. And this is a real differentiator we have. And I believe this is something which will enable us to have an edge over our competitors who are only software CPU based. Because if you compare the growth of power between GPU and CPU, you see that on this diagram, the GPU technology is really on a roll right now, and the discrepancy between the computational speed, the gigaflops per second you can have between GPUs and CPUs, is becoming wider and wider over the time. So our core technology is to build codecs, so encoding engines for video compression. And we build them from scratch. It's our own code. We, you know, there are many free implementations for all video codecs. And we believe that if we can build from the ground up all our codecs and optimized for the GPU technology, which is basically optimizing the algorithms so that they can take advantage of the massive parallel architecture of the GPUs, we think that we can have a very powerful platform that will outperform most of our competitors. So basically, that's it. We use GPUs, and it's our own innovation and our own intellectual property to do that. Let me just take a comparison between what we have today and CPU-only solutions. There is, well, a vast majority of encoders on the market today can do a very good job with CPU-only architectures, but they are not as fast as GPUs. And here is an example of one of our customers. It's a big telco we have in the United States. And we replaced one of our competitors' encoding mechanism, which was purely CPU-based. And they had something like 240 RAN rack units machines. So there was a full data center room devoted to that. And with our technology, we could replace up to 7 rack units by just one. So we replaced a full room with just one rack chassis because of the technology we have. And this will be becoming more and more important. We'll see that because of the new devices, the new screens that are driving the market today. So I won't go into details, but with just one rack unit, we can do up to 24 simultaneous HD channels encoding or 48 SD channels. So if some of you in the audience have some comparison points, I guess you can imagine how powerful this technology is. So now let's talk about future technologies. The new screens. So today everyone has got an HD or changed their main TV set a few years ago from an SD TV set to an HD TV set. Now be prepared to change again for 4K. So this is a comparison between the video resolutions we had over the past 20 years. Started with VCD, VOCD. So, well, as you can see, in 20 years, we went from, it was, I guess, 180 lines, something like that, to 4,000 lines with the same vertical resolution. Today, the next big thing we have is 4K. So, as you can see on this diagram, the red rectangle is 4 times what we have on HD today. I don't know if you already have had the experience of watching a 4K movie on a very big 4K screen, but it's really impressive. It's as impressive as the jump from DVD to HD 1080. I guess it's even more impressive because you can enjoy that on bigger screen because the technology today enables us to have bigger LCD screens, so it's really vivid and vibrant when you see that. But the problem is that the more pixels you have, the more processing power you need to process all those pixels. And if you look the number of pixels we have, it's there is also an explosion on the number of pixels to process. And the problem is that it's not a trend which will become flat at one day. It's something that I bet will continue to grow up with the same exponential model. A few words about 4K. When we talk about 4K, today it's a little bit early to really define what we're talking about. So 4K, basically it's also called Ultra HD, and here is the resolution, 3840 by 2160. So it's 4 times the HD resolution. It's slightly different from the cinema 4K, because the cinema, you know, it's not exactly the same aspect ratio we have. And today, the content we have is the same, the usual 24 or 25 frames per second, but this standard can enable up to 120 frames per second, which is also, you know, giving a more fluid movement. But this standard is not ready yet. This is an evolving standard. And one of the problems we have today is about the acquisition and all production for 4K content, which I hope are some issues that will be addressed this year and in the coming in the coming 2 years, I guess, by 2015, all that will be set up. So already we already have some 4K examples. So if you come to our stand, there is a demo of some 4K clips we have. Unfortunately, we don't have a 4K TV. So if you have a 4K TV, you can download them free from our website and see them. Okay? And so as we've seen that there are more and more pixels to process and more resolution, there is a new codec, a new norm for compression which is emerging. It's called HEVC, and it's appearing right now. And the aim of HEVC is to halve the bandwidth for the same quality as the previous, compared to the previous protocol, which was H.264. And H.264, or HEVC, it's the same name, was created to have also 50% of the bandwidth used by MPEG-2, the previous protocol. So nearly every 10 years, there are new protocols to have the bandwidth which is used so that you can have more and more pixels in the same networks.
My name is Thabet. I will do this presentation on behalf of Dr. Nabil about the National Software Quality Assurance Center. The center was established in 2012 according to government decree in the Royal Scientific Society, which is the largest applied research institution, consultancy and technical support service provider in Jordan. Just to give you a brief about Royal Scientific Society, Royal Scientific Society has 4 sectors: knowledge, testing, quality and outreach, and an additional 4 clusters. Those clusters, the clusters: energy, water and environment, industrial technology, construction, material and science, and information communication technology for development. All combined are working on national and international projects serving the community. Why do we need such a center in Jordan? This center is founded to act as a third-party consultancy between the software companies and their clients. And this will give trust between the software companies and the clients, and also will add the trust for the product itself. Okay? The center provides quality assured testing services to clients prior to going live, and these centers will enable the clients to avoid operational errors and reduce development cost. The center was officially launched by Her Royal Highness Princess Sumaya bint al-Hassan recently in 23rd of May 2013, and this is the official launch. This center has infrastructure based on HP matrix architecture, cloud-based services, and a complete IT quality management solution based in HP Quality Center and Lord Runner. The network vision is to provide software testing and quality assurance services across the region. This is our vision. Our mission is to assure bug-free software and reduce cost and time to market software products. Our team was highly trained by HP and has extensive experience in testing, including web portals, web services, desktop and client server applications, and also mobile application. Our main services is to do test consulting, test automation, performance testing, specialized test services, and managed test services. The objective of the center is to enhance software quality and performance, nationally and internationally, accelerate time to market products and services, minimize testing cost and improve predictability, transfer knowledge and skills to our clients to be self-sufficient. Who can use this center? Who can benefit from this center? Actually, the government sector, they can benefit from this sector. The private sector, the universities also, they can benefit from the center. The bank sector, the telecommunication sectors, and others. Actually, the center is equipped with HB Cloud System Matrix, HB Quality Center, HB Quick Test Professional, and also we use HB Load Runner in addition to Microsoft Team Foundation Server and other open source tools. The HB Cloud System Matrix, what we have exactly, we have just a private cloud dedicated for the center and the use of the center. This HB Cloud Matrix built on HB Blade servers and HB 3-bar storage and Matrix operating environment. The tools used in the center, we use the HB Quality Center. The Quality Center, it is web-based tools. It is used for gathering requirements, planning and scheduling testing, analyzing results, and managing defects and issues. In addition to that, it is used for digitizing specific quality process and procedures. Also, it assures the collaboration among the IT team. This is the use of the quality, the HB Quality Center. We use also another software called HB Quick Test Professional. This software supports functional and regression test automation and also used for capturing flows directly from the application screen. The HB Load Runner tool, it is used to prevent costly application performance problems in the production phase. It measures end-to-end performance, diagnoses application and system, and reduce the cost and time required to test and deploy new applications. This is the used for load runner. It's for performance testing. The core services of the Quick Center, we perform product testing and the quality assurance services, in addition to identifying and eliminating any possible weakness in software system to ensure that they run efficiently and cost-effective before they go live. This is the core service. We adopt software testing lifecycle starting from requirement phase analysis, test planning, test cases, until and ending with sign-off phase.
This year, actually, we decided to compare the situation between 2004, when we started the conference, and 2013. So basically, looking at the past and the present. This compares, for example, cellular lines in the Arab world 10 years ago, 2012, with 2012. Basically, massive growth. If you notice, for example, a country like Egypt had less than 500,000 10 years ago, now has 104 million cellular lines. Overall, the growth was from the mid-20s, around 24 million cellular lines in 2002, to over 390 million cellular lines in 2012. The growth is massive across the region. And of course, the recipe for the growth was straightforward: liberalize the market, introduce competition, and allow foreign direct investment and local investment in starting up new cellular operators. And we all remember the record prices that some of these cellular licenses fetched. We remember the $1 billion in Egypt, in Morocco, and then another 2.1 billion for the third Etisalat Misr license in Egypt. Over 3 billion by Mobily in Saudi Arabia, and then over 5 billion for Zain in Saudi Arabia, the license there. In Morocco, 1 billion for the Telefonica license. That was the golden era of liberalization in the Arab world. Governments benefited, consumers benefited from lower rates and higher access and higher coverage. And of course, investors also benefited very well from very good profits, alongside growth and lower rates. So it was a nice, perfect storm for the region's connectivity. This looks at the penetration rates in the Arab world, as well as, of course, the cellular lines per country by end of 2012. If you notice, most of the countries now are approaching or have exceeded the 100% penetration mark when it comes to cellular lines, and that again is related to multiple SIM card use and of course competition and increasing base of users, and the threshold for connectivity is much lower now. Getting connected is quite straightforward, and with the massive deployment and the new handsets, it's also spreading into teenage kids and other segments, usually underserved or unserved. Now it's penetrating in these markets as well, quite well. No monopolies. Back in 2002, it was a monopoly market. Most of the countries were monopoly markets. Nowadays, we only, basically 2002, we only had 2 markets with more than 2 operators. Now we have 15 markets that have 3 or more operators, and no monopolies remain. The others that do not have 3 or more operators at least have 2 operators or cellular operators in the region. This is a repeat slide basically of why we had the massive boom. Again, it's liberalization, investment, and privatization. We didn't really have much internet users in the Arab world in 2002. Many of the countries had internet users that number in the thousands. Now we have millions of internet users. Broadband internet users in the Arab world are already well over 60 million. And these are broadband internet users. The total internet users is over 80 or so million internet users. And of course, not only was internet in limited supply, we had virtually no broadband connections and no broadband infrastructure 10 years ago in 2002. But now we've got, again, millions of broadband users across the region. The largest broadband market in the Arab world is Saudi Arabia, followed by Egypt and Morocco, also the United Arab Emirates. In the case of Saudi Arabia, Morocco, and Egypt, it's correlated with their population size. But in a country like the UAE, it is really because of its relatively smaller size, but it's really high penetration and a good push by the operators and the government into expanding broadband connectivity. The same can be said, of course, in a country like Qatar, where there is also, like in the UAE, a massive push for fiber to the home deployments and encouraging investments in broadband infrastructure, whether fixed or wireless, in these markets. Basically, again, we've got 39 operators already having 3G networks in the region, 3G or 3.5G by end of 2012. In neighboring Palestine, they're quite ready to have 3G, but it's the lack of access to frequencies that's not allowing them to have 3G. So without that political constraint, the number actually would be 41 operators with 3G networks across the region. And it's helping. This is a look at the average revenue per user between 2011 and 2012 and 2010. It's clear, yeah. It's actually clearer on this than on my screen. And it basically shows that in countries where there is strong deployment of 3G and strong uptake of 3G, it has helped a bit in lowering the rate of decline in ARPU levels in the region. This is good lighting. Okay. So for example, in a country like Kuwait or the UAE, the decline in ARPU is leveling off a bit, and it's because of the uptake of 3G and data services, and that's contributing to the revenues collected by the operators. Sorry. LTE, for long-term evolution, 4G, is actually commercially available already in 4 countries in the Arab world: Bahrain, Kuwait, Oman, Qatar, Saudi Arabia, and the United Arab Emirates. But again, even in these markets, it's not, of course, countrywide coverage. It's within certain segments of urban centers in major cities that they actually have long-term evolution networks deployed. High definition is now actually, we've lagged the world in high definition TV. So the switch to high definition in the Arab world has been quite slow compared to other regions. But even in that, we're seeing massive progress. We have now 102 high definition, unique high definition channels broadcasting in the region, mostly pay TV channels, and we had 0 exactly in 2002. So it's a good percentage now of the total supply of TV channels, and that's of course encouraging people to also invest and buy high definition receivers and high definition TV sets. This just underlines the growth in high definition TV that we're seeing. 62 channels by mid-2012, and by the first quarter of 2013, 102 channels. So it's almost a good 80% growth in the high definition channels in just 1 year. And in some countries, we've got a strong uptake of triple play. For example, in Qatar, this is the triple play accounts in the country. Remember, it's a very small country. So you have 75,000 households with triple play services. And that's almost, assuming an average of 6 or 7 or 5 people per household, that's almost 20% of the of households, or a quarter of the households already have triple play services in a country like Qatar. The penetration rate here is out of the total population, not of households. So if you multiply by the number of average people of households, that's almost 25% of households having triple play services and actually watching TV over broadband internet, whether over copper or fiber to the home. Also on the positive side, remember, Saudi Arabia did not have much by way of internet users in 2002. Now it has millions of them, and almost 19% of them are regular e-commerce users. And that's translating well into purchases. Again, almost 11 billion. We estimate, based on our surveys, that B2C e-commerce in the Arab world has reached 11 billion a year in 2012. And of course, a lot of it is consumption in countries like Saudi Arabia, where the combination of broadband connectivity, high income levels and high employment levels amongst the population. And of course, that includes, we're always asked, people think that's too much, but that includes airline reservation, hotel reservations, and buying tickets online and reserving for hotels online. So if you factor that in, and of course, that's a big number of usual e-commerce transactions. And also, people use social media heavily, and this is basically the number of internet users that report using social media sites regularly. Almost 90% of internet users in Egypt, and almost 80% of internet users in Jordan. And the operators are awakening to the social media boom, so they also, it's a dynamic of supply creating its own demand. So it's the major operators are also putting social media presence, such as YouTube channels or Facebook pages. Similarly, all the major media companies already have similar issues, and they advertise that on their media to their subscribers or to their viewers, and that makes a positive feedback loop of people who have not tried social media before to actually try it based on an advertisement they saw or a message from their operator. This is the number of fixed line operators that have Facebook presence, LinkedIn, Twitter, and YouTube. So if you notice, most of them are already on Facebook, and the growth is 84% of fixed line users, fixed line operators were on Facebook in 2011, and that has reached 97% of fixed line operators in the Arab world by 2012. Smartphones, almost already over 50% in the Gulf countries of Saudi Arabia and Kuwait. 42% and 44% in Jordan, Egypt 8%, and Morocco, a very recent survey, 21% of handsets in Morocco are smartphone handsets. And the trend is, of course, more adoption of smartphones. Those who do not have a smartphone, many of them plan to have a smartphone as their next purchase, and the numbers are in the double digits. In Egypt, 46% of those who do not have it plan to or report planning to have a smartphone in their next purchase. And the percentage of smartphone owners that use it as a smartphone, we define using a smartphone as a smartphone by using apps. So if a user has a smartphone but actually only uses it for SMS or voice calls without downloading apps or using the pre-installed apps, that's really not using the smartphone for its full potential. And these are some encouraging facts that, for example, in Lebanon, 64% of those with a smartphone actually do report using smartphone applications. On the other extreme, to a little bit less than 40% of smartphone owners in Kuwait actually use smartphone apps. So it's basically almost a full 60% of smartphone owners in Kuwait use it as a feature phone, not a smartphone. This is the language preferences for basically when we ask the smartphone users what language do you prefer for your smartphone applications. We had some expected results and some surprising results. For example, in the UAE, because it's a country where there are many expatriates and the lingua franca in the country is English effectively, 90% reported preferring English and 8% reported preferring Arabic. In Saudi Arabia, where there is a massive Arabic-speaking population, it was almost 50-50. 47% of users said, I prefer my mobile app to be in Arabic, and 50% they said, I prefer it to be in English. The surprising one is in countries like Lebanon and Jordan, where most of the people actually speak Arabic, but then the vast majority, 91% and 94%, prefer mobile apps in English. We tried to explain that in the availability of mobile apps, the diversity and the number of mobile apps that are available in the English language. Their quality is probably higher than those in the Arabic language. And if these users in these countries are competent in the English language, that would explain why they prefer it in the English language. In Morocco, of course, expectedly English is only a quarter because it's either Arabic or French there, and 60% reported it. So basically, even in Morocco, the French component, the other languages, is much higher than the Arabic language. And also, again, that can be explained by the fact that chances are the diversity and the choice available choice of mobile apps is much of higher quality in French and English apps than in Arabic apps, because the Arab world is still not producing a massive amount of relevant mobile apps for the users. And that's, of course, an opportunity for Arabic developers, because the fact remains that most Arabic-speaking people are not very fluent in, let's not say most, a small majority of Arabic-speaking people are not completely fluent in either French or English. So I'm coming to the end below my time. It is a nice story. We saw a great growth in connectivity, but these are really the easy part of the story. Okay, how do you increase broadband connections? You allow liberalization, you dismantle monopolies, you offer licenses for international and regional operators and private investors to set up new companies, and then the competition happens, and the prices are lowered, awareness increases, and people adopt the cellular more, they adopt broadband connections more, they adopt the internet more. This is the easy part of the puzzle. But then once that pipe is here, the challenge is to translate that into real, not real, let's say, more social and economic and political advancement in these countries. And this is where we need now the governments in most of the countries to fine-tune and finalize their e-government plans, e-commerce legislation. For example, in Jordan, we still do not have the framework properly for e-commerce transactions. And we do not have an agreed upon payment processing system. So all the e-commerce players in Jordan actually use payment gateways that reside outside Jordan. So it's these little things that, many little things that need to happen before we start really leveraging the benefits of the boom and the increasing user base that the liberalization has resulted in.